Right. All right. Let me let me start by sharing my screen. And we'll start here. All right, greetings, scholars. All right, so the main announcement that we have for today is that we finally came to a conclusion with the discounted content from the bookstore with My Math Lab. So the conclusion is you guys can you can gain 2 years of full access to My Math Lab for $100. And to access it, you would have to you have to contact the bookstore. Either just go to the bookstore or contact them and explain that you're one of the students. You're waiting for the discount. So again, the discount is 2 years of full access to My Math Lab for $100. So just contact the bookstore and it's there. Okay, so last time we were working on section 1.4. I know we got about halfway through the content through the lecture. So the other half, you have to use my pre-recorded lecture to see that information. It's there. It's been there since the beginning. And so today, what I'd like to do is to take some time to go through as many homework questions together as we can. Let me check on you guys in Zoom one more time before I do this. It looks like you guys are okay. Okay, so let's hop over to My Math Lab. Hey, Google, give me a random number between 1 and 23.
Here's a random number, 4.
4. Let's start with question 4. And as always, if you have questions about anything, questions or concerns, feel free to either unmute yourself or type it in the chat. I do monitor the chat, and so that way we can try to resolve whatever the matter is. Here we're asked to find the intervals over which the given function is increasing, decreasing, or constant. So something like this, I would look at the graph. One way that we have for graphing something like this, you make a table and plot the points. Now we haven't officially talked about transformations, but the basic shape is a U-shaped curve and the leading coefficient is negative. So that means it's upside down. So if you had a graphing calculator, you can use that. And another option is this thing called Desmos. This is a free graphing website. And so you just go to desmos.com and then click on graphing calculator and this will come up. And then all I'm going to do is type in f of x, where is it? Parentheses, okay. F of x equals negative 3x squared. And that's the actual image, right? It's a U-shaped curve that's upside down. So if this is our graph, as we start to trace it from the left to the right, what is it doing initially, right? So as we trace this image from the left to the right, notice that it's increasing, right? So it's increasing as x moves from negative infinity to 0, which is A. Okay, I'm gonna suppress this, hit enter. Okay. And then with that same image, if we keep tracing from 0 to the right, it's decreasing. So it's going to be decreasing from 0 to infinity. And there is no interval where the function is constant. I totally was about to say there is no interval where the constant is function. I do that sometimes inadvertently. A little bit of dyslexia, but we're okay. Let's keep going. So let's look at this. I think what it is, I just need to slow down. I try to move too fast. Who wants to go fast, right? Hey, Google, give me a random number between 1 and 23.
Here's a random number, 16.
16. Let's look at question 16. I don't know why that takes so long. It's usually a lot faster than that. Find the average rate of change in this function as x changes from 0 to 7, right? So for our purposes, whenever you see average rate of change, that just means find the slope between the 2 points, right? they gave us two different x values. We can find the corresponding y values, and then we can find the slope between the 2 points, right? So again, for our purposes, whenever you see average rate of change, it just means find the slope between the points. So I'm going to start by getting a copy of this. Oh, you know what? It might be missing because I have it plugged in. Oh, come on. Let me unplug it. Okay. Yeah, let's try this again. Like now, for some reason, okay. This, you know me and my tangents. So with my students earlier, I mentioned to them that, if you have like Disney, on Disney, they just recently released The Little Mermaid and Elemental. So that's what I was watching right before I joined you. I was Elemental. I watched Little Mermaid this morning. I had already seen it, but just to have it in the background. And then on HBO, they have like The Flash, the recent one that came out. And so the reason I'm bringing this up, for some reason, I wanted to sit in on a discussion about the Barbie movie, because it's like it had all this potential. It seemed like it had like it was trying to make this point, but I felt like it like fell short of whatever point. And I just wanted to kind of like hear a discussion on that movie, because they were making points, but I don't know. I just felt like it was missing something. Okay, so this is question 16. It comes from section 1.4, question 53, right? That's called our question ID. That tells us where in the textbook this is coming from. So if we were to like scroll through the textbook, go to section 1.4, look at question 53, it should be the exact same question with different numbers, right? So average rate of change is just the slope between the points, okay? So let me see. We were given, so when x is 0, all right, when x is 0, what's the corresponding y? It looks like the corresponding y is also 0. And then when x is 7, the corresponding y is 35. So far already. Right? So then basically we're trying to find the slope between these 2 points. So whenever I have ordered pairs like this, I like to just label them x1, y1, x2, y2. And we're finding the slope, which is the rise over the run, which is the change in y over the change in x. So that's going to be y2 minus y1 over x2 minus x1. Again, this is our slope. Okay. So then if we're finding the slope, again, y2 minus y1 over x2 minus x1. Okay. So notice I use a blank, I replace each component with a blank set of parentheses, and then we're going to plug in the corresponding components. So y2 is 35, y1 is 0, x2 is 7, x1 is 0. 35 divided by 7 is 5. Okay, style. Okay, so we got an average rate of change of 5. I made the mistake the other day, like yesterday, I guess it was. I just wanted like I wanted some chips. And I know at Aldi they have these like $1 off brand Clancy chips or whatever, these Pringle style, but they're off brand. And so I made the mistake of getting like the cheddar. I can eat ice cream sometimes. I'll be eating pizza and I'll be fine. It'd be hit or miss. It don't always like affect me, but I ate those cheese chips. I woke up in the night with like in a cold sweat, nauseous, throwing up. I was like, golly. Please, my body was like, please do not eat that again. The average rate of change is 5. So I had to like flush my body with like a bunch of fruits, veggies, and water to kind of reset it. Cool. Okay, let's look at another one. We're gonna go here. Hey Google, give me a random number between 1 and 23.
10.
10. Let's look at question 10. A student in my last class requested 10, but I didn't realize it until I was closing everything down. Okay, so this one says the graph of a function is given to the right. Use the graph to find each of the following: the domain and range, the intercepts, the intervals over which the function is increasing, decreasing, or constant, and then whether the function is even, odd, or neither. Okay, so the domain. With an image like this, right? With an image, the domain is the very left to the very right. So how far left does this graph go? The far left is x equals -1. How far right does this go is x equals 8. So the x's go from -1 to 8. Another way you can kind of visualize domain, if we were to take this image and smush it onto the x-axis, that'll highlight the domain, right? It's, so if we took this image and smushed it down onto the x-axis, then it's going to touch from -1 to 8. Okay, and those are inclusive. It looks like it touches those points. So that means we're going to use a square bracket, -1 to 8, square bracket. Okay. And like if you haven't seen Elemental, I don't know if you've seen this other movie I'm a reference, but it reminds me a lot of this movie called Inside Out. As far as the style and the concepts that they talk about, it's interesting. I enjoy those movies. Okay, what's the range, right? So if the domain is the very left to the very right, or it's the projection. When I say projection, what it is like, imagine we had like a light bulb above this and it casts a shadow onto the x-axis. That shadow is the projection of this image onto the x-axis. That's our domain. We can do a similar thing if we move like the light source to the side, either side, and look at the shadow cast by our function onto the y-axis, right? In other words, the range is the very bottom to the very top. So if we were to smush this onto the y-axis, what y values would it touch? The lowest y value looks like it's what, -2, and the highest y value is a 1. And it touches those endpoints and everything in between. So we're going to do -2 to 1 with square brackets. Okay, let's go with that. Okay, hopefully this is all clear. If anything is not clear, feel free to unmute yourself to ask questions. Otherwise, I'm going to power through. The x-intercepts, where does it cross the x-axis? I'm going to try to eyeball it. I think with these, sometimes it'd be a little off. Up 2 and over 3. No, I think so. I feel like if we try to eyeball it, we might be a little bit off because I think it's going to be like off a few decimals or whatever. So what I'm going to do is find the equation of the line through those 2 points and then use that equation to find the intercept, right? So let's find the equation of the line. Oh no, there it is. Let's find the equation of the line through these 2 points. Here, let's just delete this. Come on, you can do it. I decided to just go ahead and get a copy of the original. Yeah, my bad is calling me. All right, let's copy and delete. Okay, we're gonna hop over here. Right there, paste. Resize. All right. So, we were trying to find the x-intercept. So for the x-intercept, again, we're going to find the equation of the line passing through these 2 points. Okay, so whenever we're working with lines, you want to have three formulas ready to go. The slope formula, rise over run, changing y over changing x. So that's going to be y2 minus y1 over x2 minus x1. Again, that's our slope formula. You also want to have point slope, right? So if that's a slope formula, point slope formula, you want to just have that ready to go. That's going to be y minus y1 equals m times x minus x1. And the way I remember that, I know I can get it from the slope formula. If I multiply both sides by the denominator and drop the 2, then I'll get my point slope formula. And then lastly is the slope intercept. That's your classic y equals mx plus b. Okay, so we want to find the equation of the line through the 2 points. We have -1 comma -2, and we have 4 comma 1. Okay, so again, whenever we have an ordered pair, I like to just label it x1 y1, x2 y2. Okay, so then let's go ahead and find the slope. So our slope is going to be xy here. Y2 minus y1 over x2 minus x1. Our y2 is 1. Our y1 is -2, 4, and -1. Okay. Notice we have a double negative, so that becomes a 3 on top and a 5 on bottom. So we have our slope. Okay. I'm going to choose the first point and plug it into y equals mx plus b. So I have a slope of 3 by 5. I'm going to let my x be 4. We're trying to solve for b, and the corresponding y is going to be 1. So then ultimately b is going to be equal to 1 minus 12 over 5. But that's going to be 5 over 5 minus 12 over 5. What is that? -7 over 5? Right? So if we tried to eyeball that, we would not have gotten this y-intercept. Right? That's why I was like, I think we need to actually work this one out. So we have our slope here, and we just found the y-intercept. So then the equation of the line through those 2 points is going to be 3/5 x minus 7 by 5. Okay? So now from there, we can use that. Now, if we want the x-intercept, we set y to 0 and solve. So if we want the x-intercept, we set y to 0 and solve. Let me put this back. Right? So then we're going to have 3/5 x minus 7 over 5 equals 0. 3/5 x equals 7 by 5. Multiply, divide both sides by, dividing by a fraction is the same as multiplying by the reciprocal. So this is going to be the same as 5 multiplying by 5 over 3. Okay. So those are going to cancel each other. We're left with x on the left. And on the right, we left with 7 by 3. So our claim is that this is our x-intercept. Again, we would not have gotten that by trying to eyeball it. I thought we could, but then I was like, no, we need to work it out. Okay. If that's our x-intercept, our y-intercept is oftentimes a lot easier. You just let x be 0. Our y-intercept is going to be, it should be the -7 by 5. Like another one that I'm kind of waiting for is like Blue Beetle. I mean, I've seen it in theaters, but it's still just fun to watch this stuff, especially when it's like new. What's really fun is when the movies are in theater and they're already on HBO and Disney. I really enjoy those. I don't know why, I just do. Okay, so we got an x-intercept of 7 by 3. Okay, let's hop back over here. All right. Determine fill what do we get? 7/3. And then y-intercept, we got a -7/5. -7/5. Okay. All right. So that was not obvious, right? This is actually a good one. Okay. So then for part C, increasing, decreasing, or constant. Okay. So increasing. Notice as we trace the graph from the left to the right, initially it's increasing. It's increasing as x moves from -1 to 4. So it's increasing as x moves from, we're going to do open parentheses, -1 to 4, close parentheses. So whenever we're doing increasing, decreasing, or constant, it should be parentheses for everything. Continue. It's not decreasing anywhere, so we're going to go with B. And then constant, continue, is constant as x goes from 4 to 8. So right here, parentheses 4, 8. So even means y-axis symmetry, odd means origin symmetry. This has neither of those, so we're going to go with neither. Okay. All right. Hey, Google, give me a random number between 1 and 23.
23.
Okay. So Kara's custom tees experience fixed costs of $300. And actually, let me check on you guys in Zoom to see if I have any latecomers. No, it doesn't look like it. Okay. Kara's custom tees experience fixed costs of $300 and variable cost of $2 a shirt. Write an equation that can be used to determine the total expenses encountered by Kara's custom tees. Let X be the number of shirts and let C of X be the total cost of producing X shirts. Then calculate the cost of producing 9 shirts. Okay. So they gave us information about her cost function. It says there's a fixed cost of $300. That means for her to start this business, she needs at least $300 to get started. That might be, who knows, the brick and mortar, or it could be renting out a space, or who knows. But that's for her to get started, she needs $300. And then for each shirt that she produces, it costs her an additional $2. So we're going to say plus 2 times X. And that should be her cost function. So if you think about it, if she produces 0 shirts, but to get started, she gets her 300. If she produces 1 shirt, it's going to be 300 plus the $2 for the shirt, so on and so on. So this should be our cost function. And then, so now that we have our cost function, we want to calculate the cost of producing 9 shirts. So we let X be 9. That's going to be 18. So that's a total of 318. What if Kara was making like a designer shirt and it cost her with this setup like a $300 to start the business and $2 for each shirt, but then she turns around and sells the shirts for like $300 or like $250 or something. Like, and that happens. It's like these insane markups. It be costing these companies like pennies on the dollars to make this material, but then they turn around and sell it. It's all in whatever they think they can convince the customers to pay for it. It don't be costing them nothing to make it. Like if you look at an iPhone, it doesn't cost them $1,000 to make these devices. It probably costs them, I don't know, maybe $30, $40, $25, I don't know. but they make a huge profit on these things because it's a name brand. They built a brand for themselves. So then people will spend more for the brand name, right? And they make huge profits on a lot of these. Okay, let's try to hang out for at least maybe 15 to 20 minutes. Hey, Google, give me a random number between 1 and 23.
Here's a random number, 1.
Okay. Write a linear function that has an indicated value. So when x is 0, y is 9. Okay. I'm being lazy. I really just want to do it here. Because they gave us the y-intercept, right? When x is, oh no. When x is 0, y is 9. So that's our y-intercept. We know our b is 9. We just need the slope. The y-intercept is 9. The x-intercept is -9. I think that's a slope of 1. You can do the y, change in y over change in x. If the slope is 1 and the y-intercept is 9, let's see if this works. So when x is 0, y is 9. When x is -9, y is 0. All right, they gave us our y-intercept. They gave us the b. We just needed to find the slope, so I just did a quick calculation in my head. If I need to show it, just request it, and I'll write it out. Okay. Man, I got another group after you all. I was like, I don't know if I'm gonna make it. Let's try another one. Oh, wait. Okay, so the y-intercept is 9. It can't be A. It can't be B. It could be either C or D. And then the x-intercept is -9, so it has to be C. That's just based on the intercepts. Okay. All right. We're missing a lot of people. Where's everybody? I'm looking at this thing. Yeah, that's a dangerous position to be in. Okay. Hey, Google, give me a random number between 1 and 23.
3.
All right, let's look at 3. So this one asks us to find the intervals over which the given function is increasing, decreasing, or constant. Hopefully you can look at this and get a sense of the graph. If you can't, let's hop over to Desmos. All right, so you go to desmos.com, click on graphing calculator. This is all free. You get something like this. I'm just going to type in, suppose we didn't know what this looks like and we wanted to look at the graph. F of x equals -2x. Here, before I write anything. This should be a diagonal line with a negative slope of 2. It just has a negative slope as we trace it left to right. And the y-intercept should be 1. Okay. So if this is our graph, notice as we trace this image from the left to the right, it falls across the whole domain. So it's never increasing and it's decreasing on all routes. Parentheses from -infinity to my negative. Okay. This is, oh, you know what I could actually use? I was talking about this with a friend of mine. She was like, yeah, I'm definitely going to invest in a standing table. Because I'm sitting like on this like folding table right now with the, computer chair. But in an instant like this, I would use a standing table so I could stand up. I mean, I guess I could just move my tablet. But the interval, it's constant. There's no solution. It's not constant anywhere. Okay. Okay. Hey, Google, give me a random number between 1 and 23.
1.
All right, so we did 1. Let's go on to 2. Write a linear function that has an indicated values and sketch the graph. So in other words, they're asking us to find the equation in the line passes through the points. Let's take some notes here. Oh. Get a copy. Yeah, that looks good. Go there. Okay. Then let's copy and delete. Okay. I know my yawns are contagious too. Because I know like this topic, it just loads you, especially after like lunch. Even if I don't eat lunch, it's just like it's tough at these hours. Let's see. Write a linear function that has its value and its sketch graph. So we want the equation of the line through the 2 points. Okay. So first, let's start by writing our ordered pairs. Okay. Party. When x is -1, the corresponding y is 3. When x is 2, the corresponding y is 9. So then when I have ordered pairs, I like to label them x1, y1, x2, y2. And let's go ahead and find the slope between these guys. So that's going to be y2 minus y1 over x2 minus x1. So then our y2 is 9, 3, 2, and -1. Okay, so then if we simplify, that's a 6 on top and a 3 on bottom, so it looks like the slope is 2. Okay, so then I'm going to use, I'll work here, I'm going to use my slope intercept, y equals mx plus b. I'm going to use the first point. I feel like it's not too terribly bad. So my slope is 2. My x is going to be -1. We're trying to solve for b, and my y is 3. So then ultimately b is going to be equal to, we add 2 on both sides, so 5. We got our slope, we got our y-intercept. So then the equation of our line is going to be y equals 2x plus 5. Let's undo. Okay. All right. Let's go one more. Just a minute. Nice. Save. Okay. Let's see. So let's just do a quick check. When x is -1, we get 3. That checks out. When x is 2, 5 plus 4 is 9. Right? So this is a line that passes through both of those points. So then what we're going to do is hop back. We got 2x plus 5. We got 2x plus 5. All right. So -1, if it's 2x plus 5, the y-intercept is 5. It has a slope of 2. So it can't be b or c because those have negative slopes. And we said the y-intercept was a +5, so it has to be d because I think a has the wrong y-intercept. Hey, Google, give me a random number between 1 and 23. Hey Siri, give me a random number between 1 and 23.
A random number between 1 and 23 is 17.
17.
What? They chose the same thing? You heard Google get jealous. I was waiting 20 minutes for it to respond, so then I went to Siri, and it was like, oh, okay. I'm gonna respond now. Like a random number 17. And then she mimicked Siri. I'm like, I wonder, like, how do they determine the random number? Like, what is it based on? Like, how are they generating these random numbers? Okay, let G be this function. Find the average rate of change. Okay, average rate of change is just the slope between the 2 points. I think I'm gonna work here. We got a solid 10 minutes. I think I might only keep you guys for 5 more minutes, just because. Okay, let's go like this. So when X is 8, the corresponding Y, sheesh. Hey Google, what's 7 times 8 times 8 minus 6?
7 times 8 times 8 minus 6 is 442.
442 minus. Hey Siri, what's 7 times 6 times 6 minus 6?
7 times 6 minus 6 is 246.
So that's Y2 minus Y1 over, it's going to be 8 minus a negative 6. Okay. Hey Google, what's 442 minus 246?
442 minus 246 is 196.
Over 14? Okay. Hey Google, what's 196 divided by 14?
196 divided by 14 is 14.
Okay. So we get this. Again, all we did was find the slope between the 2 points. I just didn't write it out. I just kind of took my notes here. I'm gonna get rid of this extra stuff. We got a result of 14. Hopefully we did it right. Okay. All right, we'll do one more. Hey Google, give me a random number between 1 and 23.
Here's a random number, 10.
10. Awesome. Okay, so we'll do 11. Notice that since I called on Siri, now she shifted gears. Use a given graph of the function to find the following. The intercepts. Okay, x-intercept, it looks like it's negative 2 and 1. I think I need to zoom out some. Right here. We said negative 2, 1. The y-intercept, it crosses once at 2. Okay. The domain is the very left to the very right. So the far left looks like it's negative 3. The far right is positive 3. And it includes those endpoints, so we're going to use square brackets. Negative 3 to 3, square bracket. Okay. The range is the very bottom to the very top. The very bottom is 0. The very top is 3. And we use brackets because we include those points. 0 to 3 in brackets. Okay. Increasing. So the graph is increasing as we trace it left to right as x goes from negative 2 to 0 and 1 to 3. Right here, parentheses, we said negative 2 to 0, and then as x goes from 1 to 3. Okay. Continue. Decreasing is decreasing as x goes from negative 3 to negative 2 and 0 to 1. parentheses, we said from -3 to -2. Then as x goes from 0 to 1. Constant is not constant anywhere. Is there any kind of symmetry? It almost has y-axis symmetry, but not quite. So there's no symmetry, so we're going to say it's neither even nor odd. Okay. All right, guys, I think that's it for me. Are there any burning questions before we go separate ways? Going once, going twice. Forever hold your piece of rice. Okay. So let me make a copy of this available. It should be shared in the box. That should be the right folder. So when this bar finishes loading, anything that you saw me writing, you'll receive a copy of it. Also, may I encourage you all to maybe check out the recordings from my other classes today, either my 9 a.m., my 2 p.m., or I got one more after you all. I'm essentially working like different questions with each student. So if you want to have a more complete experience, you can watch those recordings that I did with my other students, okay? If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, have a great weekend, gentlemen. See you next week, same time, same place. Take care. Peace.